So in section 2.4, it's a really brief section. We're just going to characterize a few key families or groups of the periodic table according to common names that are used to describe them. So the groups that we're going to give common names to, and you are expected to know these common names, are two on the far left of the periodic table and two on the far right. Now the two groups that are on the left, those elements in those two groups, 1A and 2A, they're all metals, and the two groups on the far right, groups 8A and 7A, they are all non-metals. So let's have a look at their common names. So we've got four common names that we're expecting you to know. So those elements that are in group 1A are given the common name the alkali metals, and this kind of comes back from really the alchemists, and they had recognized that when these metals are added to water, it gave them the property of being alkali. Alkali means that it turns litmus paper blue, and it also means that it turns fat into soap. They didn't really understand what was going on, but they knew that if you put one of these metals into water, it reacted really violently and it made that water alkali. So you've probably heard of people putting sodium into water, and you can see that reaction. If you look up, alkali metal water reactions, and you can find some pretty spectacular YouTube videos describing what happens when you combine those things together. Now, group 2A, the elements that are in that group are given the name the alkaline earth metals, because it was found that if you found soil that contained these elements and you added it to water, that made it alkali as well. So you could put the dirt containing these elements into water and it made it alkali. And so these were elements that were found in alkaline earth. All right, so pretty easy, the alkali metals and the alkaline earth metals. So now we're going to jump on over to the two groups that are on the far right of the periodic table. So we've already mentioned these guys, and we already gave them their trivial or common name. These are the ones that are in group 8A. They're known as the noble gases, because unless we have exceptional circumstances, they don't interact with other members of the periodic table. They literally are the snobs of the periodic table, or if you want, the royalty of the periodic table. And then it's important to recognize that people will use interchangeably with that name. They'll use the name the inert gases, because inert means unreactive. So it's a pretty boring way of describing them. I like the noble gases better, but they're called sometimes the inert gases. Okay, so next to these guys in group 7A, what have we got there? Well, the elements that are in group 7A, they're referred to as being the halogens. And this is where we kind of see a little bit of variability in the physical state. Fluorine and chlorine are gases. Bromine is a liquid, one of only two elements on the periodic table that's a liquid at room temperature. And then iodine and astatine are solids. Now, highly unlikely that you're ever going to see any astatine because it is radioactive. So certainly we won't be seeing that. Iodine's got a sort of like a purplish color. It's a crystalline material. Bromine is a brown liquid. Chlorine is a sort of a yellowish gas, and fluorine, you don't see it very often. It's highly reactive, colorless gas. Okay, so yeah, that's those guys. Now there are some other groups that do have common names, but you're certainly not meant to know them. 5A is called the pnictogens, I think it is. I've never heard a chemist talk about that. So it's PNICTOGENS. I've never heard anybody actually use it. I've only ever seen that occasionally in textbooks. And then the oxygen group is the Halogens. And again, rarely used, but you might occasionally see it. And so, you can just always Google, because every quiz, test, and even the final in this class is open notes. And you can also use the internet while you're doing those things. All right, so just a couple of other pointers about the periodic table. Don't forget that the inner transition metals that are in period 6 and 7, they are normally put underneath the main part of the periodic table in order to save space. And what's interesting about those guys is they don't have a group number. Now, something to keep in mind is anything bigger than bismuth is always radioactive. So all of these elements that are bigger, that have atomic number greater than 83, they're all going to be radioactive. So from 84 up to element 118, they're all radioactive. So you want to keep that in mind. Okay, remember we also said that 7 elements are found in nature as diatomic molecules. You wanted to remember those. They are hydrogen, and then you hop on over to number 7 and you draw a 7 to get the remaining 6. And we've already mentioned previously that you can recall these using the memory aid Have No Fear of Ice Cold Beer. So you have 2 ways of memorizing those guys. Remember, they're the diatomic 7. So start drawing your 7 at number 7, and then it also includes hydrogen. All right, additionally, we should point out that phosphorus is found in nature as P4 and sulfur is found as S8. Okay, so like I said, fairly quick section here. Hope you found the video informative.